Welcome, Algebra 1, to your radical quiz study guide. So we're going to go through this. I'm probably going to break this up into different sections for you guys so the video isn't too long. So that is that. Let's get started. Okay, so number 1 says the square root of 64 plus the cube root of 8. So first we think, are those already perfect squares? Do I know what the square root of 64 is? And yes, I do. The square root of 64 is 8. And remember, you guys should have, like I would if I were you, like while you guys are doing this, have your perfect squares, have a list of your perfect squares out. So this is going to take a quick detour, but when you're going through, like you can have this list out. Let's go through. So we can make something like this. If we have, let's see, 2, 3, 4, 5. And so we can figure out, okay, we know all of the x squared terms for all of these. So that would be 4, 9, 16, 25, 36, so on and so on. And then x cubed, you don't really have to know all of these. The big ones you have to know. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed, I don't know off the top of my head, but it's 216. And really, I would stop. You could fill in the rest. Just, if you wanted to use that for the test. But these are all different cubes. And you don't really have to know, like, your fourths. We're not dealing with anything to the fourth power, just your squares and your cubes. So if you want to use this to kind of help you on the test, I really encourage you guys to, have this out. And I'll reference back to it today when we're going through the study guide also. Okay, so let's get back to the study guide. Okay, so the square root of 64 we know is 8. And then the cube root of 8, is that one of our perfect cubes? And it is. The cube root of 8 is 2. So then it just becomes a simple operation problem. 8 plus 2 is 10. And that is that. Okay, so let's do 2. So I'm thinking, do I know what the square root of 144 is? And I look and see, is 144 in my square list? And it is. Square root of 144 is 12. Now remember, any cube root of a negative number is always going to come out to be negative. So when we see that negative, I instinctively just will bring out the negative. And then I think, okay, what's the cube root of 216? Well, the cube root of 216 is 6. And so the cube root of negative 216 is negative 6. Now that's because negative 6 times negative 6 times negative 6 gets me a negative 216. So then 12 plus negative 6 gets me 6. And that is it. Okay, so let's look at 3. I see I have a square root and a fraction within that square root. So what I like to do first is just break it apart and look at, okay, what's the square root of 49 and what's the square root of 25? And those are both perfect square roots. So I can just simplify the top to be 7 and simplify the bottom to be 5. And that's your final answer. Okay, and then the cube root of negative 127, first thing I think about is that negative. So right off the bat, I'm just going to bring that negative out because I know that no matter what, when I'm taking the cube root of a negative number, it's always going to end up to be negative. And then I can think about what's the cube root of 1? What's the cube root of 27? Well, the cube root of 1 is 1. 1 times 1 times 1 is 1. And the cube root of 27, we can look at our list. Cube root of 27 is 3. So my final answer here would be negative 1/3. Okay, so those were all like perfect square and cube roots that we can use. Now we're going to get into the ones that aren't perfect. So 54. So I want to think about what's my perfect square that goes evenly into 54. So remember, I kind of go through this list and I know, okay, well, 64 we know can't go into 54. So I go, because it's bigger, so I go less, right? And I think, can 49 go into 54? And it can't. And so some of you guys might know which perfect square goes evenly into it, and some of you guys might have to do trial and error. So you could do, okay, what about 54 and 36? It doesn't go in evenly, so we move on to 25. Okay, what about 54 and 25? Doesn't go in evenly again, so we move on to 16. Doesn't go in again, so we move on to 9. 9 works. And we know, okay, 6, there isn't a perfect square that goes evenly into 6. So that's how I break it up. So 54 we know, okay, is 9 times 6. And then I think, okay, what's the square root of 9? I know the square root of 9. That's going to come out to be 3. And then 6, we can't simplify that any further. There's no pairs within 6. So we leave it within the square root. So 3 rad 6 is my final answer. Okay, so we go through the same process with 24. What perfect square goes evenly into 24? Now we know our factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. But the only one that has a perfect square in it is 4 and 6. And so the square root of 4, we know. And then 6, just like above, we can't simplify that. We can't break it up. So it's just going to be the square root of 4, which is 2. And then rad 6 is going to stay on the inside. Okay, let's look at the square root of 40. So the square root of 40, we're again thinking, what's a perfect square that goes evenly into 40? And I know my factors of 40, 1 times 40, 2 times 20, 4 times 10. And I stop there because I know 4 is a perfect square. And 10 I can break up to be 5 and 2, but I can't break that up any further. And I don't like 5 and 2, there isn't a pair that I can take out there. So we just look at the 4. 10 is going to stay inside the square root. So the square root of 4 is 2, and then the 10 stays inside the square root. And that is my final answer. Okay, so let's look at 8. Now with 8, we're bringing the variables in. And so I'm going to look at it just part by part by part. So I'm going to look at the square root of 28 times the square root of x to the 5th times the square root of y to the 8th. And just look at it piece by piece by piece. So 28, I think about what's my perfect square that goes evenly into 28. And we can, you can do trial and error, divide by 25. We know 25 doesn't go into it. Divide by 16, that doesn't work. Divide by 9, that doesn't work. Divide by 4, that does. So I can split it up. 4, and 7. And I know, okay, what's the square root of 4? Well, the square root of 4 is 2, and then 7 is going to stay inside the square root. So whatever you can't take the square root of is always going to stay inside the square root. And then x to the 5th. Now, x to the 5th is going to be one of our exponents. So you can either think about it in two ways, and I'll show you the two ways, like one way here, one way here. So what you want to do and how I do it is I think about what's my index number on a square root. Well, my index number is 2. So what I'm going to do is, because it's a variable with an exponent on it, I can take the 5, the exponent, and divide it by 2. Well, 5 divided by 2 is 2 with a remainder of 1, because it goes in evenly 2 times with 1 left over. So what that means is x to the 2nd can come out of the square root, and x to the 1st power is going to stay inside. So the 2, the number that goes in evenly, comes out, and the remainder stays in. Now, the other way of doing it, besides dividing by the index number, is actually writing it out. So y to the 8 is y times y out 8 times. That's 6, 8. And then we look for groups of 2 of the same thing. We have one group of y's, another group, a third group, and a fourth group. And there's none left over, so what's going to actually come out is y to the 4th. And then I just look at, okay, I can write everything that's on the outside. So that's the 2, the x squared, and the y to the 4th. So 2x squared y to the 4th, and then what stays on the inside of the square root is the 7 and the x1. And we don't need to write the x1, so we just write 7x. And that would be my final answer. I'm going to try and focus this a little better. I feel like it's a little, oh, that did nothing. Maybe still, I feel like that's okay. We'll just go with it. Okay, so let's move on. I'm just going to do 9 and 10 in this section, and then I'll do the next kind of chunk in the next video. Okay, so 9, we have the square root of 200 a to the 4th b. So again, I'm just going to split it up into the square root of 200 is going to be one thing, a to the 4th, and then b. So I'm thinking, what's a perfect square that goes evenly into 200? Well, hopefully you're thinking, I know, it's 100. 100 times 2 is 200. And we know the square root of 100 is 10, and then 2 is going to be left on the inside. So that can simplify to be 10 rad 2. Now, a to the 4th. Now, I prefer to use like the division method, but if you guys want to write it out, you can write it out. And I just think, like, often I just do this mentally. What's 4 divided by 2? Well, that goes in evenly with no remainder. So that means it goes in evenly twice. So that means a squared is going to come out of the radical, and nothing is going to be left on the inside since there wasn't a remainder. And then now this one, b, well, again, there is no exponent, so you can think about it as 1 divided by 2. Well, 1 divided by 2 is none with a remainder of 1, right? And so that means none can come out, and b to the 1 is still left inside the square root. And so then again, I just kind of gather what's the same. So we have 10 and a squared, that's going to be on the outside of the square root. And then what's inside the square root is going to be 2 and b. So rad 2b. And that is my final answer there. Okay, the last one is now dealing with cube roots. So still, we're going to break it up exactly the same as we did like up here. So cube root of 16 times the cube root of x to the 5th times the cube root of w to the 6th times the cube root of y squared. So I first just start with my number. Is there a perfect cube? Remember, these are my cubes that goes evenly into 16. And there is. We know 8 goes into 16. 8 times 2 is 16. And we know, okay, the cube root of 8 is 2. And then the cube root of 2 is going to stay on the inside. Remember that cube root has to be there. You have to write it, like if we're taking the cube root of something, you have to then still write the cube there. Okay, and then we can use our division method to help us simplify the variables with the exponents. So my index number is 3, so we're just going to do 5 divided by 3. That goes evenly in once with a remainder of 2. So that means x to the first power can come out, and then the cube root of x squared stays inside. Okay, then we move to the next one because, right, the 1 can come out. The remainder of 2 stays inside. W to the 6th power, so we divide 6 divided by 3. Well, that goes in evenly with no remainder. So that means w squared can come out of the cube root, and there's nothing left on the inside. And then last one, 2 divided by 3. Well, 2 divided by 3, it doesn't go in evenly with a remainder of 2. And so the cube root of y squared just stays as is. So then I combine everything that's on the outside of the cube root. The 2 is on the outside, the x is on the outside, and the w squared is on the outside. And then the cube root on the inside is 2, x squared, and y squared. Okay, I'm going to pause the video there. So that was just kind of the chunk on simplifying radicals, both with just numbers and with variables. So there you have it. Go take a break, do what you need to do, and then come back and we'll do the next section. Okay, I will talk to you guys soon.